Hello, this is Mrs. Boots. In this lesson, we're going to solve radical inequalities. Now, radical inequalities are very similar to radical equations. There's three parts, very similar to the three steps that we had before. Part one is actually what we did before. Part one is your IRS, where you solve, okay? This is where you solve the original problem. Part two is the insides, all right? We're going to set the stuff under the radical greater than or equal to 0, okay? Because we're doing square roots, and for square roots, we cannot have imaginaries. We're not going to have negatives, so we want it greater than or equal to 0. Part 3 is to graph your solution. We're going to graph the solution on the number line, okay? 3 parts. First part, same old, right? So let's look at the first example, walk through it. IRS. Is the radical isolated? Yes. So we raise it to a power. What power do we raise this radical to? It's a square root, so we're going to square both sides. The square and the square root cancel. I'm left with the 2x plus 4. Always drop your inequality symbol down. Don't change it. Lots of students accidentally put an equal sign in there and then they lose everything. 4 squared is 16, not 8. I've had students do that. 4 squared, oh, that's 8. No, this is not 4 times 2. It is 4 squared. Okay, now how do I solve for x? Remember, that's our third step. So I'm going to subtract the 4 from both sides. I get 2x less than or equal to 12. Very good. Divide by the 2. And I get x is less than 6. Less than or equal to 6. Awesome. Now we have to do part 2. See the stuff under the inequality? 2x plus 4. That quantity has to be greater than or equal to 0. Okay? We still solve for x the same way. Subtract the 4 and divide by the 2. All right? This is the other half of my answer. Now I need to combine them by putting them on the number line. Remember, negative 2 goes on the left. 6 is going to go on the right. So you put the smaller numbers to the left, bigger numbers to the right. What kind of dot does the 6 get? Oh, yes, it's all coming back. It has to be a closed dot because there's an equal sign. What kind of dot is the negative 2 going to get? Yep, closed dot. Now, which way do we shade? From negative 2, the arrow points to the right. So I'm shading to the right. From the 6, the arrow points to the left. So I'm shading the middle. If I were to write this in interval notation, I would write this as negative 2, comma, 6 with square brackets. Okay? So technically, this interval notation is the solution, or I could write this as negative 2 less than or equal to x less than or equal to 6 and combine it that way as well. Okay? So part 1, IRS, same as it was before. Part 2, set the inside of the radical greater than or equal to 0. Part 3, graph on the number line. You can write it in interval notation or in the inequality notation. Example 2. Is the radical by itself? No. We're going to have to subtract that 2 and move it to the other side. Okay, so we subtract the 2. I have square root x minus 3 less than or equal to 3. Now, is the radical by itself? Yes. That means I can square both sides. How do I know that I'm squaring it? Yep, it's a square root. Remember, the stuff inside comes down. All of it. So I have x minus 3 less than equal to 9. Now I need to add that 3 to the other side to get x by itself. So x is less than 12. Less than equal to 12. That's the first half of my solution. Well, how do I get the second half? Remember that stuff inside? X minus 3. That stuff has to be greater than or equal to 0. So we move the 3 by adding it to the other side, and that's our solution, the second half. Put both numbers on the number line. 3, 12. What kind of dot does the 3 get? Closed dot. What kind of dot does 12 get? Closed dot. From the 3, which way do we shade? Which way does the arrow point? Points to the right. So I'm shading to the right. From the 12, which way does the arrow point? To the left. So I'm shading to the left. This means the shading's in the middle. And so in interval notation, we would write this as a square bracket, 3, 12 with a square bracket. In inequality, I would write it as 3 less than equal to x less than equal to 12. Easy enough. Here's part 1. This is part 2. And here's part 3. Okay? Let's look at example 3. Is the radical by itself? No. What is there that I need to get rid of? The 4. The 4 out front. Now, what do I do to get rid of that 4? Do I subtract it? No. What's that 4 doing? It's multiplying. The opposite of multiply is divide. So we're going to divide by 4. Both sides, divide by 4. Super easy, okay? So I have my square root x minus 2 greater than or equal to 1. Now I can raise it to the power. What power do I raise it to? Yep, we're going to square it. Okay, so when I square it, I have my x minus 2 greater than or equal to 1. Yeah, 1 squared is 1. It's not a big fancy deal, but it's still 1. Now I have to add 2 to both sides, and I get x is greater than or equal to 3. That's half my answer. That was part 1. Now I got to do part 2. How do we do part 2? The stuff inside the inequality. What's inside? X minus 2. What do we do with that? You set it greater than or equal to 0. So I add 2 to the other side, and I get x is greater than or equal to 2. Okay, so let's put on the number line. I have a 2, I have a 3. What kind of dot does the 2 get? The 2 gets a closed dot. What kind of dot does 3 get? Yep, it's got the line underneath, it gets a closed dot. Now, from the 2, which way do we shade? The arrow points to the right, so I'm shading to the right. From the 3, which way do I shade? Oh, also to the right. Now here's where students get confused and they just start coloring in the whole number line. Where do I have both arrows? Yeah, it's only up here that we have both arrows. Okay? So in this case, our interval notation would start at 3 and would go to infinity. Or we would simply say that x is greater than or equal to 3. We don't have to worry about the 2 at all. All right? Example 4. Is the radical by itself? We have 2 radicals in this problem. Well, is each one on an opposite side? Yes. So we're going to go ahead and square both sides. How do we know we're squaring it? Because they're square roots. Take the stuff on the inside and drop it down, just like you did before. So now I have 3n is less than equal to 4n minus 3. Okay. So let's subtract the 4n to move it to the other side. Minus 4n minus 4n. Not a big deal. 3 minus 4 is negative 1. So I have negative n less than equal to negative 3. Got to get rid of the negative in front of the n. So I'm going to divide by negative 1. Uh-oh. Is there a rule? Is there a rule about dividing by negatives when you're using inequalities? Yes, there is. So now we have a positive n, and I have a positive 3, but that inequality symbol is going to flip. It's going to change directions. Now you're looking at it and you're saying, well, Mrs. Boots, we have two things on the inside. You're right. So I have 3n has to be greater than or equal to 0, and 4n minus 3 has to be greater than or equal to 0. The 3n is easy, because when you divide by 3, 0 divided by 3 is still 0. So n is greater than or equal to 0. Notice both of these point in the same direction. So yes, on my number line, it's going to be okay. Now, move the 3. So we have 4n, and we add that. Greater than or equal to 3, divide by 4. n is greater than or equal to 3/4. So put them on the number line in order. I have a 0, I have a 3/4, and I have a 3. They all get close dots. Now the tricky part, figuring out which way to shade, right? So, for my 3, I shade to the right. For my 0, I shade to the right. For my 3/4, I shade to the right. Which area has all the shading? Just over here. That area has all the shading. So it's everything greater than 3. So my interval notation would be a bracket 3, comma, infinity. And that's all we need. We only need this part because these other two parts will be satisfied. All right? Does that make sense? It's a little crazy. Just remember to select where the arrows overlap and you'll be fine. Now let's look at example 5. Oh dear. Yeah, this one's going to be a little harder, but that's okay. Just take it one step at a time. One step at a time and the problems sort out. So, first step is the radical isolated. Oh yes, that radical is by itself, so it's fine. So I raise it to a power. What power will I raise it to? We square it. We're going to square both sides. So when I square the left, yeah, I'm going to have to write it twice. That's okay, we can do that. So I have negative x plus 1 less than x plus 5 times x plus 5. Okay, let's just go ahead and multiply that out. Negative x plus 1 less than x squared plus 5x plus 5x plus 25. Easy enough. What kind of equation is it? What kind of function is that? What's the highest exponent? 2, which means it's a quadratic. For quadratics, we have to set them equal to 0, okay? So I'm going to add this x and subtract the 1. Okay, add the x, subtract 1. Okay. I end up with a 0, right? I still got my less than symbol. X squared, 5 plus 5 plus 1, 11x, 25 minus 1, 24. Well, that's easy to factor, right? Let's just go ahead and factor it. X is in front. What multiplies to give me 24 adds to give me 11? 8 and 3. This is where it gets tricky, because figuring this one out and where the arrows go is going to be much more challenging because it's not individual pieces, right? It's not individual pieces. Because both of these could be negative, and a negative times a negative will be a positive, which will be greater than 0. So what we're going to do, this would be x equals negative 8. This would be x equals negative 3. We're going to put this all on the number line. Oh, I have one more part. Yes, this was all part 1. Okay, now we got to do part 2. I guess set the stuff under the radical. Negative x plus 1 greater than or equal to 0, right? So subtract the 1. Negative x greater than or equal to negative 1. And then, yes, we're going to have to switch that inequality symbol. Now we're ready. Now we're ready for our number line. Okay, so put all the values on there. Negative 8 is the furthest left, then negative 3, then positive 1. Notice it's not to scale, okay? I don't expect you to put all the little tick marks on there. Okay, the 8 and the 3 have open circles because we only have the less than symbol. The 1 gets an equal to. With the 1, I already know that it's going to be shading to the left. Okay, so I don't need to worry about anything bigger than 1. But for these guys, I'm going to plug in some numbers and check it, okay? I'm going to check, really easy one to check, is x equals 0. 0 is right here in between 1 and negative 3. So I'm going to plug in 0. So I would have square root of negative 0 plus 1, is that less than 0 plus 5? Well, that would end up being 1, so is 1 less than 5? Yes. So I'm definitely going to shade in that area. That satisfies my inequality. Just to make sure, let's plug in a number over here. Okay. Well, what's a good number over there? We could plug in anything. We could plug in, let's see. I was going to go with negative 8, but that won't work. We'll just go with negative 5. We'll plug it in the calculator, right? So now I have to check a number in between negative 8 and negative 3. So I'm going to go with negative 5. All right, so I have the square root, negative of negative 5 plus 1 less than negative 5 plus 5. Okay, so this is the square root of 6 less than 0. Is the square root of 6 less than 0? No. Okay, so I don't shade right here. In between the negative 8 and the negative 3, do not shade. All right, now let's look over here. Past the negative 8, I'm going to go with negative 15. X equals negative 15. Why negative 15? Check it out. Square root negative of negative 15 plus 1. That gives me 16, right? So I have the square root of 16. Is it less than negative 15 plus 5? Less than, let's see, that's negative 10. So 4 less than negative 10. No. All right, 4 is not less than negative 10. So we don't shade past the negative 8 over here on the left. So the only part that satisfies the equation is from 3, negative 3, over to 1. We include the 1 and we don't include the 3. In pre-calculus, you will plug numbers in between the intervals to check things. So this is just kind of a little practice to get you started on what you're going to do in pre-cal and calculus.